definitions. আজকে হচ্ছে বাকিগুলো করি. Right, so we're doing thermophysics. Last definition was the absolute scale. এখন হচ্ছে মেইন গুলোতে যাই. মেইন গুলো মানে হচ্ছে যেগুলো কমনলি জিজ্ঞেস করে. Right, so first definition is what is internal energy. These are very common and important as well. So internal energy definition, what is it? Right. Random or average, right? It is the sum of the random kinetic energy and potential energy of the particles. তারপর হচ্ছে sum of random এখানে একটা word দিলে better হয়, distribution of kinetic energy and potential energy of the particles. Next হচ্ছে first law of thermodynamics. What does the first law of thermodynamics state? It's done by either doing right. So first law of thermodynamics, it states that the increase in internal energy of a system takes place when work is done on the system and heat is transferred to the system. Right. First law of thermodynamics, del U equals del Q plus del W. We'll be doing that today a lot. Next, you have these are very generic ones. But I'll look at a specific heat capacity. Right. It is the amount of energy needed to raise the temperature of 1 kg substance by 1 degree Celsius or 1 Kelvin. And what is specific latent heat of fusion? It is the amount of energy needed to keep solid to liquid or vice versa. Absorbed release of it's basically the amount of change that's needed. So তুমি যদি gain করো তাহলে কি হবে? Melt করবা আর release করলে তুমি কি করবা? Freeze করবা. That's just absorb বলাটা appropriate না. Latent of fusion data ওটা কি? Solid to liquid, right? It's also the same amount of energy needed to go from where? Liquid to solid. But liquid to solid তাহলে তুমি energy gain করবে না lose করবা? হ্যাঁ, তার জন্য absorb বললে তো তুমি just এক দিকে বলতেছো। এটা দুই দিকেই হয়। It is the amount of energy needed to change the state of 1 kg substance from solid to liquid or vice versa. There's an important point here. Very good. At a constant temperature. এছাড়া হচ্ছে thermophysics-এ আর কিছু এরকম নাই। আমরা করতে গেলে কিছু পাবো maybe, but these are the more common ones that I've seen recently. Okay, so these are your definitions. Now let's write down the equations from thermophysics. Okay, so equations gulo ki ki hobe from thermophysics. There are 3 equations. Tomra figure out koro ki ki equations. Konta? Del U. Acha. Ha bolo. Right. So the first equation that we have is del U is equal to del Q plus del W. But তোমাদের syllabus এটা অন্যভাবে লেখে. Do you know what do they do? এভাবে লেখে না. Plus Q plus W. What Q? Small q. So small q actually has a meaning. Small q মানে হচ্ছে heat is provided to the system, or big q heat is given by the system. So the alternate equation, I've seen they accept both of them, but the other one that we have here is del U is equal to Q plus W. And a q, the one here, this represents heat taken in. And this W here represents work done on system. Work done on system. And what is del U? Change in internal energy. I think you know by now that internal energy পুরোপুরি measure করা যায় না. We can only find the what? Change in internal energy. So for solids and liquids, you can't find the internal energy, but for gases, you can. How can you find it for gases? Yeah, so the 3/2 kT formula use for it, or you multiply with the number of particles that you have in the sample. Estimate power there. Okay, so this is the first equation that we have. Del U equals to del Q plus del W. And right, another equation. Right, del U now, the U, internal energy is equal to the sum of random K plus potential energy. Ekhane ekta catch ache, this equation for gases is different. Gases er jonno equation e kirokom dekhte. Right, exactly. So for gases, also not random K, what K? Translational K, just half mv square. Okay, so it's equal to half m a c square. Mone ache eta ki chilo? Root mean square speed. Okay, so okay, is that clear? Right, two more equations. It actually কোনো equation না তোমরা বলছো তার জন্য দিয়েছি এখানে, but rest of them mc q equals to del q is equal to mc del t, and the c here is known as what? Specific heat capacity. Specific heat capacity. Our change in temperature to absolute change, so degree Celsius or degree Kelvin, দুটাতেই হচ্ছে same, so you don't need to worry about that. Okay, one last equation from this chapter. ঠিক আছে, del q, del q little problem নাই, equals to mlf or v. মনে আছে কি এগুলা? Latent heat of fusion or vaporization, right? It's like a O-level question. Ideal. Also, no, yeah, the questions are because typically it's ideal gas and thermophysics হচ্ছে একসাথে যায় ওরা আলাদা যায় না. Right, so this is it, and there's one important graph in this entire topic, which is which graph? Yeah, the heating graph. So এটা কিরকম দেখতে হয়? এটা হচ্ছে টেম্পারেচার ডিগ্রি সেলসিয়াস টাইম সেকেন্ডসে। হ্যাঁ বলো। হ্যাঁ, ফ্ল্যাট হয়, তারপর উপরে যায়, ফ্ল্যাট হয়, উপরে যায়। Correct. Okay, this is your melting, and this is your boiling. Right, so I think we are ready to try some questions. It's a ছোট chapter, এখানে অত problem হওয়ার কথা না. It's very repetitive, I think. Clear? Aluminium. বের করার জন্য এক্সপেরিমেন্ট হ্যাঁ আছে তো সিলেবাসে না সবসময় ছিল তো অনেক কোয়েশ্চেন আছে তো কি বলো কি যে অ্যালুমিনিয়ামের হচ্ছিল স্পেসিফিক ক্যাপাসিটি কেমনে বের করতে হয় হ্যাঁ হ্যাঁ ইউ হ্যাভেন্ট ডান এনাফ পেপারস আমি দেখাচ্ছি আমার রিভিউ কোয়েশ্চেনের মধ্যেই তো হ্যাঁ আমি দেখাচ্ছি তার লেটেস্টে যদি না আসতে আমার কি সিলেবাসে নাই আচ্ছা ওকে এই যে so this is one of them this is the one with the fusion process 2004 yeah but syllabus to change right? Oh so you're saying that 2004 questions are invalid
Yes.
Why so acha এটা 2000 এটা 2000 May 2004 so you're saying যে এই কোশ্চেন আমাদের নাই ও মানে কি বললে তাহলে what do you mean তুমি সিলেক্টিভ ভাবে দেখবা যেটা পছন্দ ওইটা আছে আর যেটা পছন্দ না ওটা নাই আচ্ছা so let's see the next one এখানে হচ্ছে equation graphs I think everything is covered okay let's try some questions so first হচ্ছে we'll start with আমরা সিরিয়ালি করে যাই because এখানে কিছু রকম হচ্ছে বাদ দিব না গ্যাস লস যদি আসে তাহলে ওটা আমরা পরে ব্যাক করে করব হ্যাঁ বলো thermal physics yeah okay ঠিক Okay, let's start one by one. These are mostly structured questions. So the first one, using simple kinetic model of matter, describe the structure of a solid. With low kinetic energy. Describe the structure of solid. I think kinetic energy would become movement. Anyone else? Vibrational kinetic energy. হ্যাঁ বলো yeah আচ্ছা ওকে আমি বলি কি করতে হবে হ্যাঁ হ্যাঁ so the way এইটা ঠিক আছে so you need to say that the particles are arranged in regular lattice arrangement with the particles undergoing vibrations about a fixed position. Now এখানে যদি হচ্ছে লোটা অ্যাড করতে চাও কোথায় অ্যাড করবে with particles undergoing vibrations with low kinetic energy about a fixed position. I'm going to confirm করে নেই 2 marks তো this is February. Let me check. Specific latent heat of vaporization is much greater than specific latent heat of fusion for the same substance. Explain this in terms of spacing of molecules. Why is it that latent heat of fusion is exponentially higher for vaporization is exponentially higher? What's the reason behind this? Because of the spacing. So why is it so large? So you go from solid to liquid. Let's say the amount is 10. You go from liquid to gas, the amount is 500. So the changes are different. So when you go from solid to liquid, it's like just that. And when you go from liquid to gas, it means it goes from here to that wall. So to take them that far, you need a lot of energy. Okay. So in terms of spacing of molecules, the answer would be to change a state from liquid to gas, the particles need to be separated by an exponentially large distance, which requires much more energy compared to changing from solid to the solid to liquid. I'll check the answer though. This is so do you know what was the Mark's answer from the previous one? Was not there. That's what he is. Yeah, because I feel the kinetic energy part is subjective. Low K vibration, because high temperature of solid like let's say titanium, right, can go up to 5,000 degrees Celsius. That's a lot of temperature. The vibration is really fast. Okay, so we can't really say it's a low Ke vibration. Better, drastically বলতে পারো, মানে অনেক দূরে নিয়ে যাচ্ছে না। আচ্ছা, so এখানে বলছে particles, atom molecules closely touching together, repeat in pattern, vibrate over a fixed position. First answer. Second বলছে much greater increase, ওই increase-টা হচ্ছে এটা করছে, underline করছে. So you have to talk about the fact that there's a large change. To change state from liquid to gas, the particles need to be separated by an exponentially large distance, which requires much more energy. I think increase what they can imply. Why did the underline increase itself need to be separated, or I think this is fine. Okay, let's move on. So to the heater supplies energy at a constant rate of 0.045 kilogram of a substance. The variation with time of the temperature of the substance is shown here. The substance is perfectly insulated from the surrounding. This is the heating graph out there. Determine the temperature at which the substance melts. Right, minus 100. The power of a heater is 150 watt. Use the data from figure 3.1 to calculate the specific latent heat of vaporization for the substance. So power দেওয়া আছে এখানে আমাকে latent heat of vaporization বের করতে হবে. It is 0.045. So আমার ফর্মুলাটাকে লিখে নিতে হবে. Q equals to ml. Q is the amount of energy provided. That's 150. When Q is going to be what? Power into time equals to ml. Power হচ্ছে 150. আমরা time বের করব from the graph. এটা হচ্ছে or কি fusion বলছে না vaporization. So vaporization হচ্ছে এই পয়েন্ট থেকে স্টার্ট করে, which is 3, and it goes 8.5, 8.6. So 8.6 minutes, so into 60 seconds. There I say. এটা হচ্ছে from what it is actually, it is exactly 8.5, but 6 নিতে পারো, ফোন the problem নাই। ওরা মার্স স্কিমে কি করে প্রবলেমটা, তোমাদের কেমব্রিজ হচ্ছে they don't give any variation, like they want it exactly, and I feel like হচ্ছে they give you values that are very specific, like 1, 1.5 or 2. এর মাঝখানে কিছু দেয় না। মার্স স্কিমে হচ্ছে এটার জন্য যেমন হচ্ছে they didn't allow any leniency, একদম 5.5, মানে 8.5, no 6, no 4. So এখন হচ্ছে risk হচ্ছে I don't think there's a risk though. তোমার answer কি আছে 8.6 দিলে? না না আমি বুঝছি আমি দেখতে চাচ্ছি তোমার হচ্ছে ফাইনাল অ্যান্সারটা যদি রাউন্ড অফ করো does it match the same answer or not তাহলে প্রবলেম নাই যেমন এখানে অ্যান্সার আসার কথা 1100 হ্যাঁ 0.5 0.6 একটু বেশি স্ট্রিক্ট হয়ে যায় বোঝা যাচ্ছে না I think যেটা তোমার মনে হয় ওইটাই লিখতে হবে একটা জিনিস হচ্ছে just let me clarify something এখানে একটা সিম্পল ওয়ে আছে his problem is that অনেক সময় এক্সামে মনে হয় এটা হচ্ছে এদিকে বা এদিকে বা এদিকে বা ওইদিকে রাইট এটা সলিউশন কিন্তু you guys learned in grade 9 do you remember what was the solution yeah so the rule was that ওই যে যখন হচ্ছে তোমাদের একটা if you remember alternate to practical paper এর মধ্যে এরকম স্কেল আসতো একটা মিটারের মধ্যে তোমার কারেন্টের ভ্যালু বের করতে বলছে আর পয়েন্টারটা হচ্ছে এরকম এক জায়গায় সো তখন 3 ছিল 4 ছিল and you have you have to write an answer right কি লেখা 3.5 মানে আমাদের হচ্ছে মাঝখানে যদি হয় একদম you take 3.5 এদিকে যদি হয় তাহলে কি নিবা 3 না you don't make up numbers or if it's more this way what do you write 4 so you can't like say I think you just said 3.45 তো এত ডিভিশনই তো নাই you're basically assuming there are 100 divisions in the small box there এটা কেমনে পারো and that's not possible ওইটাই তো ওই অ্যাজাম্পশন করতে গেলে তো এক্সামিনার ওরকম মার্ক দিবে so either you take the lowest or the highest or the middle কোনো অন্য কিছু নিও না so 8.6 8.75 এগুলো তো দেখা সম্ভব না right so if you stick to these values you'll find that matches
I don't think they give so much time
না ওই যে no the thing is এখানে টাইমটা কি আসলে 8.5 right এখন না হচ্ছে one of you said যে এটা 8.7745 আসছে তার তো এটা কেমনে সম্ভব বলো এটা তো কোনোভাবে পসিবল না so the thing is that whenever you have an instrument either you take the lowest the highest or the what middle এখান থেকে কিন্তু uncertainty develop হয় so এই তিনটা ছাড়া অন্য কিছু নিও না that's the rule out there B is basically your particles are taken very far apart when they go from liquid to gas. So solid particles are like this, liquid particles are like that. Gases, the particles are very far apart. So if you want to take them this far apart, you need to provide them a lot of energy. So therefore, the energy needed to change state is extremely large. Right, এটা কত আসছে 1.1 into 10 to the power 6. Or a unit is a kilojoule, so divided by 10 to the power 3, 1100. No, 8.5 দিয়ে করবো এটা হ্যাঁ বলো হ্যাঁ এটা 5.5 হবে right 5.5 হ্যাঁ so 1100 suggest what can be deduced from the fact that the section Q on the graph is less steep than the section P. That's an easy question. Ki hobe? Right. So higher the specific capacity, what the graph, steeper the graph. Okay. So ekhane bolche what can be deduced? Q is less steep. So it has what specific capacity? Low specific heat. Sorry. The steeper it is, the lower specific capacity. Yeah. Ekhane ki bolche? Suggest what can be deduced from the fact that Q on the graph is less steep. Q is less steep, so it has a higher specific capacity. Sorry, high hope it. Q has higher specific capacity compared to P. Gradient হচ্ছে gives you something that is proportional to 1 by C. So যত বেশি হচ্ছে specific capacity তত কম gradient হয়. They're inversely related. Actually, you have problem with 2 Afra? Problem with 2C2. Okay, right. Right. So define specific heat capacity. It we have done before. So it I can just stick there. এখানে বলছে a sealed container of mixed volume or fixed volume of V n molecules, mass m, everything given here. State an expression in terms of V and P for the Boltzmann and the Boltzmann constant for the thermodynamic temperature of the gas. It is from the next topic, but আমরা দুইটা একসাথেই করব. Your Ke or P equals to what? Yes, so PV equals to nRT at the formula. Let's just write all of them. PV equals to nKT are at the formula. This is a small k, by the way. Therefore, you have P equals to 1/3 nm c square. Etar alternate হচ্ছে P equals to 1/3 rho c square. Rho is the density of the gas. Our last formula হচ্ছে আমাদের হচ্ছে K half m v square is equal to what? 3/2 kT. These are the only 4 equations we have from thermodynamics. Oh yeah. So এখানে বলছে write an expression in terms of V and P constant for the thermodynamic temperature. কোনটা use করব আমরা? Yeah. So it's going to be PV equals to nKT. Show that the translational kinetic energy EK of a molecule is given by EK equals to 3/2 kT. So I gave this derivation in your notes, and it was, I think, 7-8 steps. Remember the big one? But there's a shortcut here. Shortcut ta kemne korte hoy keu jano? So amra ki likhbo age? Right. So first we write down P equals to 1/3. যেহেতু just আমাদেরকে 2 marks দিচ্ছে, we'll take some shortcut here. আমরা কি লিখতে হবে direct? Nm by V c square, okay? Nm by V. তারপর V টাকে ওই সাইডে নিয়ে যাব, হ্যাঁ বলো? Volume, right? So PV is equal to 1/3 nm c square. এখান থেকে হচ্ছে PV equals what? nKT. We won't take nRT কারণ এখানে n টা ক্যান্সেল হয়ে যাবে. So nKT equals to 1/3 nm c square, and then just simplification. So n cancels out. You have into 2/2 korbo, so you get 3/2 kT is equal to what? Half m c square, which is your K. Okay. Half kemne asche? Okay, we multiply by 2/2. So what happened is I took the 2 here and I took the 3 out there. And then I took the 3 from here to there, and I brought the 2 down here. Just rearrange them. Okay. That's what I did. That's it. Explain why internal energy of the gas is equal to the total kinetic energy of the molecules. Right. Who wants to answer this? Both? Right, exactly. So for gases, a first statement in the হবে. For gases, what is what? Potential energy is 0, right? So for gases, the potential energy is 0. Since internal energy is the sum of what? Is the sum of K and P. Internal is equal to K. I think it should be fine. Like del U equals to K plus 0 for potential. I don't think so, but it's actually explained, right? It would be safe to just mention about it. Does anyone know why is potential energy 0 for gases? right? So আমি এটা just পাশে additionally দিয়ে রাখি potential energy is due to intermolecular forces. That's what potential energy is, right? Due to intermolecular forces. Since gases have negligible or no force, P is equal to 0. C. Gas in base supplied with thermal energy Q with reference to the first law of thermodynamics. Why the increase in internal energy of gas is Q? Why the increase in internal energy of the gas is Q? Thermal. So, right. So first, let's try to break down the equation here. What's your del Q going to be? Del U equal to del Q plus W. Because on the gas super, so we can directly write that. And এখানে বলছে the gas is supplied with thermal energy Q. তার মানে এটা হচ্ছে Q হচ্ছে. And they said that with reference to the first law, why increase in internal energy? So এটা যে চেঞ্জটা হবে, why is it only Q? ওরা বলছে there's no change in volume. Oh, acha, fixed volume. Yes, very good. So work done at Juno, there's a formula. Do you guys remember what was the formula for work done on gases? Del? No. Right. So work done for gases, it's important, is equal to P times what? Del V. Our pressure constant volume change. In this scenario, there's no volume change. So if there's no volume change, there can't be any work done on the gas or by the gas, right? So therefore, del Q is the Q. Work done is 0. Hence, del U equals to del Q, right? So how do you put this in words? So tomorrow I can mention korba, the gas is at constant volume, which means what? Which means no work done. Means no work done on the gas or by the gas. Then you add that all the heat provided is internal energy. Then you write the equation, because del U is equal to del Q plus del W, where del W is what? 0. Use the expression in B2 and the information in C1 to show that specific heat capacity is given by this expression. You have trouble with this one. Okay. So B2 expression ki korse amra? B2 hocche EK equals to 3/2 KT, and CI হচ্ছে এটা. আচ্ছা, easy আছে. আমি বলি কি করব এখানে? কি আমাকে বলতে পারবা কি করব? Yes. Change in U equals to change in Q, right? And change in Q is heat provided, right? MC, right? Just simplified, right? So the increase in internal energy is kinetic energy entirely. এটা আমরা কোথায় হচ্ছে establish করছি এই যে এখানে, right? So I can say that this is how much, or এই যে এখানেও লিখছিলাম আমরা 3/2 KT. So KE, আমি লিখে নিতে তোমরা বুঝবা কি হচ্ছে, and this is del Q. So this is what's happening here. K is going to be 3/2 KT equals to, this is MC del T. আমার এখানে হচ্ছে এই চেঞ্জটা আর এই চেঞ্জটা কি হবে? ক্যান্সেল আউট হয়ে যাবে. So C is equal to 3/2 K by M. So that's a match for it. So 3K divided by twice M. Do you understand? So they're saying that whatever heat has been gained directly becomes increase in the Ke of the particles. So you can use that to figure this out. In any random question. I think that the way they maintain it in every question, right? I feel like they want the answers in the right significant figure. এখানে কিন্তু কোনো evidence নাই, because I haven't seen them say cut marks is not right significant figures, but ওরা যখন answer করে ওরা কিন্তু সবসময় হচ্ছে maintain করে, কি maintain করে, but কেমনে maintain করে, how do you know what significant figure your answer should be? হ্যাঁ, so the data যেটা provide করা ওইটা ম্যাচ করতে হবে, but ডেটার মধ্যে যদি অনেকগুলো টাইপ থাকে তাহলে সবচেয়ে lowest নিতে হবে. If you follow that, you'll see your answers perfectly match, which means they do use a method to write the answer, right? I feel like you should do as well. Otherwise risky হয়ে যায়, because otherwise যেটা এডএক্সেল হয় ওরা মেনটেন করে না, ওদের অ্যান্সারের পাশে 3-4টা অপশন দেয়, 1120, 1100, 1124 বলে allow all, but তোমাদের এটা কোনোদিন করে না, right? So that's why I feel like it's better to be safe. We don't know. The করলে তো করলো, right? ওটা তো তোমাদের আচ্ছা, ওটা তো হচ্ছে লাইক গুড অ্যান্সার ব্যাড অ্যান্সার করে, ওখানে মেনশন করা থাকে না. I understand the sample ওখানে কিছু বলে না ওরা, so that's why I feel like maybe it's not important. আবার কিছু কোয়েশ্চেন থাকে, I don't know if you have noticed, ওরা বলে that give the answer to 3 significant figures, so তখন তো it's mandatory, so I feel like maybe it's not mandatory, otherwise ওখানে বলার কথা ছিল না. কোয়েশ্চেনের উপর ডিপেন্ড করে না, মানে কোয়েশ্চেনের ডেটা যেটা ইউজ করছে ওইটার উপরে বেস করা হতো, কোয়েশ্চেনে তো বলবে না, কোয়েশ্চেনে খুবই রেয়ারলি বলে, মানে I probably seen 1 or 2 questions entirely যে খালি জিজ্ঞেস করছে একবার. আচ্ছা, the container B is now replaced with one the container is now replaced with one that does not have fixed volume. Instead, the gas is able to expand so that the pressure of the gas remains constant as thermal energy supplied. Suggest with a reason how specific capacity of the gas would now compare with the value in C2. So আমরা যেটা করব is এটাকে নিয়ে না, এটা নিয়ে করার কিছু নাই. Right. I mean to draw করে দেখে সবাই দেখো কোশ্চেনটাকে বুঝাই তোমাদেরকে. So container is now replaced with one that does not have a fixed volume and the gas is able to expand. Do you know what happens when a gas expands? Yeah, it's work done on the system or against the, like by the system, right? So you can say it's losing energy, right? So এখানে কিন্তু work done এর জন্য minus কি হবে, W, okay, because it's giving energy away from the system. Yeah, so del U should be equal to Q minus W. So এখানে আমাদের যে এনার্জি ছিল আমরা previously assume করতাম all that energy was coming from where, heat, but এখন যেটা পাচ্ছি এটা কি সেমটা পাচ্ছি না কমটা পাচ্ছি, কম পাচ্ছি নাকি বেশি পাচ্ছি? আচ্ছা, আমি একটু রিফ্রেশ করি, let me finish the question. I think questionটা দেখা দরকার তোমাদের. বলছে so that the pressure of the gas remains constant as thermal energy is supplied. So তুমি কি করতেছো এখানে, thermal energy provide করতেছো, and think carefully, it's a very important question for you, okay? So তুমি thermal energy provide করে যাচ্ছ, thermal energy provide করলে what is the gas supposed to do? Heat up. But this gas not only heats up, it also what in the same time expands. The question is, how would that affect the specific capacity of the gas compared to what you found earlier? Earlier, the gas did not expand. So do you think the specific capacity is going to be higher or lower than before? That's my question. Higher. Why? More thermal energy is needed to increase the temperature by the same amount. Yes, very good. কি হচ্ছে আমি বলি, previously আমি যা thermal energy provide করতাম all went where? To the gas, and gas took it entirely and raised its temperature. Right now, all of it doesn't go to the gas. Some of it is used by the gas to what the system, expand the system. So energy can't we take this as like a loss to the surrounding? And if energy loss takes place to the surrounding, specific capacity ki beshi ashe na kom ashe? Beshi ashe, because now you require what energy to raise the temperature? More energy. বুঝছো? বুঝো নাই? না, decrease. Less energy মানে তো হচ্ছে you need a specific capacity amount of energy needed to raise the temperature by 1 Kelvin. less মানে কম লাগবে, right? Higher specific capacity means the system requires more energy or less energy? More, right? So এখানে would the system need more energy or less energy? More energy, right? তোমরা কি বুঝছো নাকি আবার বুঝাবো? এই যে আমি জাস্ট বলি এখানে তোমাদের this is the scenario where there is no expansion, তখন তুমি যা প্রোভাইড করতেছো heat, it's in the form of what? Q. And the del U here will entirely be based on what here? Q. আর কোনো তো W এর কোনো কাজ হচ্ছে না, এটা আমরাই লিখে আসছি কিছুক্ষণ আগে। But now you have a container here যেটাতে তুমি যখন হিট দিচ্ছ, হিট নিচ্ছে এটা, বাট হিটটা ইউজ করে ও নিজেকে আবার একটু কি করতেছে, এক্সপ্যান্ড করতেছে, because the volume increases. তার মানে it's using which energy to expand? The energy you gave. So does it have all the energy to raise the temperature, or some of it has been lost? Yeah, some of it is lost to the surrounding to expand it, right? So wouldn't it mean that you need to provide more energy than before? And that's what literally specific capacity is. How much energy do you need to raise the temperature? So you now need what amount of energy to raise the temperature? More, okay? So